So good afternoon to one and all. So in the previous class, we have discussed about the current transformer, potential transformers. Okay. So these are the instrument transformers. We have discussed about transformation ratio, phase angle, and its error. So all the things we have already discussed that. Hello, is it audible?
Yes, sir.
Screen is visible?
Yes.
Okay. So we have already discussed the construction, working, and its equations, derived the equations of that, all the things of the CT and PT. So if you know that one, then we have to differentiate the what is the difference between current transformer and potential transformer. So this is the last topic of the fourth chapter, actually. Last topic of the fourth chapter. So the difference between CT and PT we are going to discuss here now. So already we have discussed that the current transformer we have discussed about that. Okay, three types of current transformers are there: wound type, bar type, and toroidal type. Correct. Okay. So those all the types we have discussed, and we have observed that it is actually series transformer. We have observed that one. The potential transformer parallel we are tapping that one, so that potential transformer we have considered as parallel transformers. Okay. So the secondary of the current transformer we have discussed that one always in the short circuit. We were using one switch in between that. Okay, we were using the switch in between the meter over there. So to bypass that one, we were using the switch. Whenever we want to remove the CT emitter and all the things, and that time by closing the switch, here only we are passing the currents over there. But in the potential transformer, it will be act as open circuit always, because whatever the voltmeter has, it has very high resistance. It has. This voltmeter has very high value of resistance. So on that condition, so it will always act as an open circuit one. So these are the major differences we have to remember that. We have to remember these two are the major differences we are going to call that. Here the line is there. So we are going to consider this line as a primary and the secondary here now. So it is connected in series. The CT is connecting in series here now. So sometimes this current transformer, it is also called as the series transformer we are going to do. The potential transformer, what we are going to do, PT, here the primary winding is different, secondary winding is different here. Here we are taking one point, we will connect that one, and with respect to the ground, we are giving to that one here. So it is connected in parallel here now. So this one potential transformer is also called as parallel transformer we are going to do. And I told that one here we are connecting, this is the secondary of winding we are going to consider. Here the emitter is there, here the emitter is there, very less resistance it has, so all the current it will flow here, and for the maintenance purpose anything we have to remove, on that condition we are going to use this switch as closing switch. If the switch is closed, all the current will flow in the this closed path only here. So it acts as always, it is acts as a short circuit only, because of it has very less resistance here now. This meter has very less resistance, so it will act as always short circuit here now. So because of this voltmeter, it has very large resistance it has, which is connected here now. So because of large resistance, what will happen? Will opposes the flow of current here now. Only less current will flow here, and it will always act as a open circuit here. Open circuit. Like this, the differences are there. One by one, we'll discuss now. See here, it can be treated as a series transformer under virtual short circuit conditions, because it is connecting in series. So the primary winding is itself, it acts as a bar, whatever the line is there, that acts as a primary winding. So we are connecting in series only here there. So for that reason, the virtual conditions, it is acts as under virtual short circuit conditions we are going to call. So it is a series transformer here, current transformer. This one, it can be treated as a parallel transformer here. No? It can be treated as parallel transformer here. No, under open circuitry condition here. No, it is act as open circuitry. For that reason, they are telling it is under open circuitry. It has act as parallel transformer. The secondary must be always shorted over there. The resistance of the emitter, whatever the current transformer means, what we are going to measure the current. The high level of the current we are going to bring into low level of the current. But the potential transformer means the higher voltage value we are going to bring into the lower voltage. So whatever the secondary winding is there, where we are going to connecting the emitter, that side we are using always short circuit condition, because this emitter has very less resistance, negligibly small resistance it has. If the resistance is small, then it acts as a short circuit only. So the secondary must be always shorted here. But here voltage across these two points we have to measure here now. So the voltmeter we are going to connecting here in this point, these 2 points we are going to connect, and that condition it has the voltmeter whatever we are using, that has very large resistance over there. So it will always act as a open circuit here. See, secondary is nearly under open circuit conditions here. It is under open circuit condition, it is going to call that. A small voltage exists across its terminal as connected in series, because the resistance is very small here. No voltage drop across this resistance will be small only. So if the high voltage is there, then just a minute. So a small voltage exists across its terminal as it connected in series here. It is connecting in series, and always it is in the under short circuit only. So the voltage drop across will be very small, because there is the resistance will be very small over there. But here the large value we are using here now, if we are considering as a open circuit, so voltage drop across these 2 points will be product of I into R. Because of very high resistance, that voltage drop will be more over there here. So a small voltage exists across its terminals as connected in series here. Now full line voltage appears across its terminal here. Now full whatever the line voltage is there, same line voltage it is going to appear across its terminal. Second one, a winding carries full line current here. Whatever the line current is there, that same line current it is going to exit, because it is connected in series over there. The winding is impressed with the full line voltage here. Now whatever the we are connecting at point with respect to the ground here now, the primary, and that connection it is going to impress with full line voltage. Whatever the line voltage is there, same line voltage we are going to apply here. So the primary current and excitation varies over a wide range here. Whatever the primary current is there and excitation is there, it is going to vary over a wide range. It is going to vary. We can increase that one, we can decrease that one. So we can vary one wide range here. So the line voltage is almost constant here, because example मैंने बोलता हूँ अभी आपका घर में ये एक बोर्ड है, उसमें चेक करो वोल्टेज सेम रहते हैं. उसको फ्रिज लगाओ, उसका करंट चेक करो, और एक बल्ब लगाओ, उसका करंट चेक करो. द फ्रिज का करंट है ऑलमोस्ट इट इज 15 एम्पियर रहते हैं, बट एक लैंप का करंट रहते इसको 5 एम्पियर रहते. The current is variable with respect to the load, but the voltage we are maintaining constant voltage here now. Yeah, going to किसी का भी घर में check करो, voltage constant रहते हैं, but current is not constant over there because this depends on the load over there. So the line voltage is almost constant. Hence, exciting current and flux density vary over a limited range here. Now, line voltage is constant, but the current, whatever the excitation current and flux density, it is varying according to the limited range. It is going to vary over. The primary current is independent of the secondary circuit. Here, the bar we are using here now. So here only it acts as primary here now. The secondary we are tapping here. Okay. So if we are affecting, we are adding something load and all the things to the primary, secondary side, it will not affect because it is connected in series over there. It is connected directly to the line is act as a primary winding over there. So does not affect anything over there. Okay, primary current is independent of the secondary circuit, but आपको ट्रांसफार्मर में देखा होगा, for the potential transformer it is not like that. The primary is depends on the secondary here now. If we are adding load in the secondary side, the primary voltage or primary side, it is going to vary over there. So for that reason, the primary current always depends on the secondary circuit conditions here for the potential. So because of one line, it acts as line only here, no? So needs only one bushing as the two ends of the primary windings are brought out through a same insulator here now. Same insulator से हमने line लेके आए वाला रहते. For that reason, only one bushing is required. So the cost of the bushing will be reduces here now. But for the potential transformer, two bushings are required when the neither side of the line are at ground potential here now. Both sides, because it is connecting to the line means up to the ground, it is like a supply only, voltage only here now. So this side also we have to use the bushing here now. So these are the simple differences of the line current transformer and potential transformers here. If you have any doubts, you can ask me. So it completes this chapter. It completes the 4th chapter. So any doubts, you can ask me. If you have any doubts, you can ask. I'm asking to you people only. Is it audible or not? Is it audible?
Yes, sir.
Any doubts?
No, sir.
No. So I declare that the 4th unit is completed here. The 4th unit is completed here and here. So we have discussed about transducers as well as instrument transformer. Both we have discussed, and the question is already given in the starting only, I think. Assignment question is given or not? I have already given the assignment question. See, listen carefully. You don't have time. So day by day, you have to complete your work. Don't keep the pending. Assignment questions diye na already last time, shayad?
Yes, sir.
So 4th assignment already I have given at the starting only, I think. Okay. So we'll start the 5th unit. I don't know where it is. I'll open just unit PPT of 5th unit. Oh, that is digital instrument is there. Okay. See the unit 5 that is called digital instrument is there. So we'll discuss the unit 2 we have discussed about already. Second unit that is called analog instruments we have discussed that one. The same basic things it is going to apply for the digital instruments here. Okay, so the difference is that for the analog instrument we were considering that it is the pointer is there. This pointer it is going to indicate that one where the reading is there. We were going to use the calibrated scale. We were going to use. We have to the where the pointer will stop. That pointer value it is going to indicate that one. That is analog instruments we are going to call it. But the digital instruments, what they are going to give directly the value it is going to display in the digital value here. The digits it is going to display that one 14.508 and all the things. So this one we were studied in the second unit. The analog instruments already we have studied in the second unit, but the digital instruments there are different methods are there. So that is digital instruments is there in the fifth unit. We are going to discuss in the today's class. So the main objective of this unit is to you people should have to understand the principle of digital instruments, digital voltmeter, digital multimeter, energy meters, Q meters are there. Okay, LED, LCD displays are there. So that is the main objective. You have to understand, you have to analyze that one, which is the instrument, what it is going to do, how it is going to operate. Okay, the operation according to the, at least you have to draw the block diagrams like that we are going to. That is the main aim of this chapter is to design for you people. So this is the syllabus for the subject actually. This chapter, the syllabus is digital voltmeter and its types here now. First is digital voltmeter. Its type we are going to discuss. After that one, digital multimeter. Electronic counter is there. Some counters are there. Quality meters, that is called Q meter we are going to call. Electronic energy meter, whatever in your houses you are using now, that is called electronic energy meter only we are going to call that one. And LED, LCD displays you know, 7-segment display and LED display, LCD display. What is the function here now? They have, there is no any derivation and all the things, only the block diagrams and explanation, block diagram and explanation for this syllabus here. So this is the complete syllabus of the digital instruments here. So before starting this syllabus, digital voltmeter and its type, we have to discuss about some introduction part of the digital instrument about that one. So introduction part we have to discuss, then we will go for the actual syllabus here. Hardly, according to me, it will take, except this class, it will take 4 hours to complete this one. 4 hours and last unit that is 2 hours are enough. 4 plus 2, total 6 hours are enough for me to finish that one. Today is 19, up to 30, I will get around 8 lectures in that one. We can take this many classes, we can finish that one. Okay, no need to worry about that. The syllabus of the measurement and instrumentation EMI subject is in control. We can finish any time over there. If we have taken 1 or if you want to complete before 25, then we will take one extra class 1 to 2, then we can finish that one. That is not necessary actually. So we'll start the introduction part today. Okay. So before starting the syllabus, in the tomorrow class, we'll start the syllabus. So the introduction part, before starting that one, according to this in a syllabus, some assignment questions I have chosen. To all of you note down these questions. How many questions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions are there here. There are 5 types of digital voltmeters. For that reason, 5 questions extra came here. Take the questions. The first one is explain ramp type digital voltmeter with neat diagram. This is one type of digital voltmeter actually. Out of 5 types, this is one type of digital voltmeter. Explain ramp type digital voltmeter with neat diagram. That is first question. Second one, all of you who is having pen and paper, you write down. Who don't have pen and paper, you take the screenshot. Explain Q meter with neat diagram. Q meter is nothing but that is called quality meter. We are going to call that. That is a quality meter. Next, explain working of true RMS reading voltmeter. Explain working of true RMS reading voltmeter with neat diagram. RMS voltmeter, which one it is going to display? That is RMS voltmeter. With neat diagram or block diagram, explain the working of digital multimeter here. Digital voltmeter is different, digital multimeter is different. Fourth question is explain with neat block diagram working of digital multimeter. I can ask after closing this one, anybody I will randomly ask. If you are taking or not, I will check that one. Explain with neat diagram working of dual slope type digital voltmeter. This is the one type of digital voltmeter again here. This ramp type, true RMS type, dual slope type, integration type, successive approximation type, like that. 5 types are there in the digital voltmeters. So explain with neat diagram block working of digital multimeter. Next one, explain with neat diagram working of dual slope type digital voltmeter. 7th one, draw and explain integration type digital voltmeter. Draw and explain integration type digital voltmeter. Integration type digital voltmeter. This is the sound. Okay, next one. Explain digital measurement of time period here. See, we have to measure the digital measurement of time period measurement. That one counter it is going to give here, no, in the counter time period how we have to measure. Explain digital measurement of time period. Next, explain electronic counter and its mode of operation. Different frequency modes are there, time period modes are there, different operation modes are there. The counter, electronic counter. So based on that, you have to explain that one. Explain counter and its mode of operation. Counter and its mode of operation. Next one. Explain working of digital frequency meter. Explain working of digital frequency meter with block diagram here. Digital frequency meter is that is also counts in the electronic counter only. And last question, draw the block diagram of successive approximation type here. Digital voltmeter and explain it. So dual slope type, integration type, successive approximation type, and ramp type is there. One more, which one it is? RMS value here. Now 5 types are there, 5 types of digital voltmeters are there. So these questions you have to write answer for this one. So after completing the 5th unit only, I will put the, when the 6th unit will start, on that period I will put the link for the uploadation of the assignment, each wise assignment 1, 2, 3, 4, 5, 6. All 6 assignments you have to upload in that link. Then only you can get the good term work marks. Okay. So you have the practical oral examination for this subject. So that one also you be ready. I think for the practical Tuesday, you have given the last date to write up part. Okay. So tomorrow is we are going to work on the Tuesday timetable. Anyhow, up to Monday you take the time. So Monday I will put the link for the practical lab write up to upload in that one. because to check that one, it will take another 2 to 3 days for me. Then I will finalize the marks. After that one, I will not encourage any further late entries and all the things. Okay, so these are the assignment questions. Next, we'll go for the introduction part of the digital instruments here. Introduction of digital instruments. So the digital instruments means we are going to consider digital voltmeters only. Okay, so for reference, we are taking voltmeter. You can take energy meter or whatever it is. So voltmeter is an electrical measuring instrument used to measure potential difference between 2 points. The voltage to be measured it may be AC or DC. We are going to use a voltmeter. It may be AC or DC, and the digital instrument we are going to call. What it will do? It is going to measure the potential difference between 2 points. It is going to measure that. There are 2 types of voltmeters are available for the purpose of voltage measurement. We have 2 types of voltmeters are there. Those 2 types of voltmeters are nothing but based on their operation and their measurement method, we have classified those voltmeters into 2 types. Those are analog and digital voltmeters. Analog and digital voltmeters. So in your houses also, you can check that one. Some people's, almost all the people's in your houses, the wall clock is there. That is analog only. वॉल क्लॉक है ना, सबके घर में वॉच है ना, वॉल को माउंट किए हैं. इधर 12 दिख रहे, इधर 6 है, इधर 3 है, इधर 9 है. ओके, एक बड़ा पॉइंट है सिंगल एंड एक छोटा पॉइंट है और एक थोड़ा मोटे पॉइंट है. So this is second, it is going to indicate, this is hour, this is minute, it is going to indicate. How many of you are having this type of watches? आपके घर में है ना ये watch? Yes or no? So this is analog watch. We are going to call that one here now. We are going to, by pointing out, it is indicating that one. But in your hand, some people's example, I am using this digital watch here. See, this is value. It is going to detect that one directly. It is going to show the number. It is going to show this one. This is called, that is going to show the time here now. This is the time is 2:32. Directly you can consider that this is 2:32. It is going to display that one. Here the small point, it is going to indicate 2, and the bigger point, it is going to indicate to the 32 here. Like that we have to assume here. Here no need to assume and no need to calculate anything. Directly it is going to give the display. Like that, the voltmeters are there available in both analog and digital. The voltmeters are available here. Okay, just a minute. Bolo. Okay, so welcome back. Some people, they are telling slide change nahi ho raha, slide change nahi ho raha kya?
No, sir. No, sir.
No, sir.
Then why you people are sitting silently? You have to tell, na? So instead of this reading mode, now which slide is visible? कौन सा slide visible है बोलो?
First, sir. First.
First, sir.
सेकंड स्लाइड नहीं है?
No, sir.
नहीं सर, एक ही दिख रहा है सिर्फ।
ऐसा है क्या? Then something is problem. Then just a minute. Now, एक मिनट अभी चेक करेंगे। कौन सा दिख रहा है अभी?
Assignment.
अभी now which one is visible?
Assignment.
वही दिख रहा है।
Assignment ही है क्या? Then it is a problem. Just अभी देखो कौन सा दिख रहा है?
Syllabus.
Now अभी कौन सा दिख रहा है?
Assignment.
असाइनमेंट दिख रहा है ना अभी?
Yes, sir.
चेंज हो रहा है?
Yes, sir.
Now which slide is visible?
Advantages.
Okay, very good. Sorry, remember you. So this all the things we have not with. This is the syllabus actually. I have shown already, but you told that is screen is not visible. You can note down that. So you take the screenshot directly. This is the assignment questions. You take the screenshot. जिसको visible नहीं था वो screenshot ले सकते हैं. Taken? Have you taken the screenshot of assignment?
Yes, sir.
Yes sir.
So we'll go for the introduction part. So there are two types of voltmeters are there. One is analog, another one is digital voltmeters. Okay, analog voltmeter and digital voltmeter. Analog voltmeters generally contain a dial. Analog voltmeter means I have taken the example of that one. So it has one dial is there, that is called pointer. We are going to call that one. It is going to indicate the value over there. So dial with a needle here. Now this is the needle and here a dialer is there. This needle over it according to the measure and hence displaying the value of the same. So it is going to accordingly it is going to display, not display, it is going to indicate the values over there. So analog meters generally contain a dial with needle moving over it according to the measure here. Hence it is we are going to display here now. It is going to show that one here now. It is going to, this is the value. Like that, it is going to show that. So in the digital, what will happen here now? With the time, whatever the technology, it is varying here now, going based on that, the voltmeters, analog voltmeters are replaced by the digital voltmeters. Analog voltmeters are replaced by a digital voltmeters here now. But due to the same advantages associated with the digital system here, some advantages are there. Digital system, so same advantage, because of that same advantages will show that we'll discuss about the advantages also. So because of those advantages, the digital voltmeters are now in the usage now here. So previously we were using the analog meters, so now the analog meters are replaced by a digital meters here now, but all not, it is not 100% not it is displayed here now. Just now I asked that one, how many of you are using a wall clock? All of you, almost 80% people in your houses, you are using a analog watches only here now. Yes or no? But in your hand, it is replaced almost 80%. Some maximum 80% of people nowadays, they are using the digital watches over there. So like that. So although digital voltmeters do not fully replace the analog voltmeters. So digital, whatever the digital voltmeters are there, they have 100% not replaced by the digital instrument. Analog instruments are not replaced by 100%. So some places still we are using analog meters only. We are going to prepare, especially in the research lab and all the things, because of this active devices in the digital meters and all the things. They are not prepared for the digital. They will go for the analog only. So still there are many places where analog voltmeters are prepared over there, over digital voltmeters. So still so many places are there. They are going to prepare for the analog voltmeters. Digital voltmeters display the value of AC and DC voltage being measured directly as discrete numerical instead of the pointer deflection on a continuous scale as in analog instrument here. So it is going to give the display value, it is going to give the direct, it is going to give the display of the value here now. So like a analog meters, it is going to give the continuous operation and all the things. So it is not going to go over there like that they are saying here. So this is a just introduction of the digital voltmeters here. So it has some advantages, I told that one. So those advantages associated with the digital voltmeters here. Digital voltmeters. Mudul. Okay, so advantages associated with digital voltmeters here. So what are the advantages of digital voltmeters? We are going to discuss now. So analog voltmeters are replaced by digital voltmeters means it should have some advantages. The digital voltmeters have some advantages over there. So because of that one only, the analog voltmeters are replacing by a digital voltmeters. Yes or no? So that is the reason and what the advantages we are going to discuss here. Readout of digital voltmeters is easy as it eliminates observational error here. I will consider that one. So थोड़ा क्रॉस से देखो आप ये वैल्यू 12 बोल के मैं लिख रहा हूँ, इधर 11 बोल के लिखता हूँ, इधर 10 बोल के लिखता हूँ. How much you can say that one here now? According to this you consider 12 and half. इस साइड से देखा तो ये 10 and half दिखते हैं. So these are the observational errors are there, whatever you have studied in the first unit. So those observational error we can eliminate by using a digital voltmeters. Digital voltmeters is eliminate the observational error. So here 11 is there, here 12 is there. Example, I will give here the pointer here now. How much you can consider that one? कितना consider करते आप? 1 2 3 4 5 again here now. I like this, I will give the point here now. 3 4 5 6 7 8 9 here now. So how much you are going to say? That is the observational error. But if it is digital is there, directly it can display that is 11.7 here. Like that, it is going to display value. So we can eliminate the observation error here. Error on account of parallax approximation is entirely eliminated. This is the approximation here now. ये कितना है? 6 है क्या 7 है? This approximation we can eliminate here. Reading can be taken very fast. इसको point count करते बैठने के काम बच जाते हैं. This point no need to count this one 1 2 3 and all the things. Directly it is going to give the value L1.7. So very fast we can do that one. So we can take the reading here. So output can be fed to memory devices for storage. You can, for the future purposes, we can store this value also. We can connect directly to the storage. We can connect that one. Okay, versatile, and it is going to give the accurate answers. Compact and cheap. The watches are very small sizes are there. No voltmeters and all the things. So because of the digital technology, low power consumption is there. Portability is increased. So the whatever the portable values and portable the structure is that is increased here now. So it will has the high accuracy here now. So these all are the advantages of digital voltmeters here. These many advantages the digital voltmeters have. For that reason, the analog instruments are replaced by a digital voltmeters over there. Okay, so this is advantages. Now, so we have shown this is a digital voltmeter. देखो अभी digital voltmeter कितना है? आपने मशीन लैब का लाइव देखने के टाइम देखा होगा शायद, एनालॉग वोल्टमीटर्स देखा है ना? Have you seen the analog voltmeters? So इतना बड़ा वाला रहते हैं वो, उसको डिस्प्ले इधर ऐसा स्केल वाला रहते हैं, इसमें एक पॉइंटर है ना? ये कंपैरेटिवली ये छोटा है ना? Yes. So that is the advantages, we can say that one. So the block diagram of digital voltmeter, we will discuss that one. If you understood this one, then you easily we can use that one here now. So this is the block diagram. Actually, the input signal we are going to give here. This is the pulse generator we are going to give. It is going to generate a pulse here. Whatever the input signal is there given to here, it will give the output, the pulse, the rectangular pulses it is going to give here. So the width of this one and the frequency, actually this circuit digital voltmeters, it consists of both analog components and digital components are there here now. Both are there, but what we are going to consider, it is the width and frequency is controlled by the digital here now. Digital components it is controlled by, and the amplitude here it is controlled by the height of this one, amplitude is controlled by the analog instruments we are going to call that. I will tell that one later. We'll tell that one. So this output of this one, it is going to give the AND gate. The AND gate is like this here now. A and B inputs are there. If it is 0 0, the output will be, I will tell that one, 0 1 1 0 and 1 1. When the output of this one will be 0 0, AND gate ka output kya hai? 0 0 1, that is 0 1 0 0 1 1. When both the inputs are high, then only it is going to give the output. So this is the train pulse we are going to consider, that is always 1 year. This train pulse is always 1 year. When the pulse generator also it is going to send the 1 here now, it is going to give the positive triggered, it is going to give here now. So by using a NOT gate, this positive triggered is converted into negative triggered here. It is converted into negative triggered, means this output is 1, this one it is going to give 0 here now. So this decimal display, what it is going to give, it is going to count number of pulses it is going to count, which is equal to the input signal here now. That one it is going to display the value here. That one it is going to display the value here. So this is the operation of and construction and working here now. The output of input signal is connected here now. The pulse signal is also connected to the decimal display here now. This is the pulse generator it is going to take here now. So the AND gate here it is going to give, if it is positive triggered, then the NOT gate it is going to convert into negative triggered. That is called analog to digital conversion only we are going to call it. So each block what it is going to do we'll discuss in the part here now. The construction and working we'll discuss here now. So and input signal is there. First it is a basically signal which voltage we are going to measure, that one we have to give as a input signal here. Next one, actually pulse generator, what is that one? Actually it is a voltage source here. No voltage, it is a source of voltage. Whatever the input signal is there, that one it will give to the AND gate here now. How it is going to use? It uses digital, analog, and both techniques it is going to use. To generate the rectangular pulse, it is going to generate. It can use, it is going to use analog, digital, and both here now. It is going to use here. The width and frequency of the rectangular pulse is controlled by digital circuitry inside and generator, while amplitude and rise time, fall time is there, that is controlled by the analog circuit. This is the very important thing you have to understand here. See, this is the rectangular pulse is there here. So this width and frequency will be controlled by the digital circuit. The amplitude means this one, and the time taken to rise here now. Here, this is the rising time. Here, this is the rising time. It is a falling time. Then again, rising time and falling time. That is controlled by the analog meters. That is analog circuits. It is controlled by that. And gate here now. It gives high output only when both the inputs are high. If both the inputs are 1, 1, then it is going to give the high output here now. When a train pulse is fed to H, along with rectangular pulse, it is going to provide, say, an output having train pulse with the duration same as the rectangular pulse here. It is going to give the provide the output as a same as the triangular, rectangular pulses from the pulse generator here. Digital display, what it is going to use? It is going to count the number of impulses, hence the duration, and display the value of the voltage on LED or LCD display. It is going to display that one. It is going to count the how many impulses are there. Then it is going to give that one. Here, only the block explanation they have given here now. So the working, how it is going to operate. First, the unknown voltage signal is fed to the pulse generator here. I have shown that one. The unknown is fed to the pulse generator. The pulse generator is going to give the signal to the AND gate here now. Taking the two inputs from the pulse and this is train pulse and this pulse generator, it is going to give the output here now. This one converted into another output here now. That one here, it is going to count and it is going to give the output here now. See here, unknown voltage signal is fed to the pulse generator, which generates a pulse whose width is proportional to the input signal. Whatever the width is there, same like a output input signal here. Now same width input it is going to provide to the AND gate here. So output of the pulse generator fed to one leg of the AND gate here. Whatever the output of the pulse generator is there, it is given to the AND gate here. So the input signal to the other leg of the AND gate is train of pulses here. It is a train of pulse we are going to use that one. That is always one we are going to use here. So now we have taken the for the AND gate, we have taken one leg, one input from the pulse generator, another from the train of pulses we have taken. Then output of the AND gate is positive trigger train. Here one is there, then there one is there, then that is a positive trigger. Then what will happen? The output of the AND gate is positive trigger train of the duration, same as the width of the pulse generator here now. Whatever the width is there, that pulse generator width is same. That is same of the input signal. Next, it is same like a input signal only. Na? If it is width of the pulse generator same means that is like a input signal only here. So output of the AND gate is positive trigger train of a duration same as that of width of the pulse generator. Duration and same as that width of the whatever the input signal is there. So this positive trigger train is fed to the NOT gate. It is going to fetch. So NOT gate, if it is 1, then it is make 0. 0 to 1 opposite here. Now here positive triggered is there, then it is going to convert into negative triggered, it is going to convert. So it is inverter we are going to call. This positive trigger train is fed to the inverter, which converts it into a negative trigger train. It is going to convert into negative trigger train. It has converted. Next, what will happen? The output of the inverter is fed to a counter, which counts the number of triggers in the duration, which is proportional to the input signal here. So this output of the inverter or NOT gate, we are going to give to the counter here now. That counter, what it is going to do? It is going to count the number of triggers here now. Positive trigger, negative trigger, how many triggers are there total, it is going to count. So according to the proportionality to the input signal, it is going to give the signal duration here now, triggers and duration, which is proportional to the input signal here. Now that is called whatever the is proportional to the voltage under measurement. Proportional to the input signal means we have how much voltage we have given, that much voltage it is going to triggering pulses, it is going to use amplitude, and the width is defined by a duration here. So thus, counter can be calibrated to indicate voltage in volts directly. Whatever the counter is there, we can calibrate to indicate the voltage in volts directly. We can calibrate that one. So this is the construction and working of the digital block voltmeter here. Now this is the digital voltmeter here. Actually, these digital voltmeters are, so one more is that this one. So we can see the working of digital voltmeter here. Now instead of this one, this is the block diagram and all the things. Directly you can see this block diagram here. What it is going to do, we are going to take the input signal here. Here attenuator or amplifier we are going to consider. If the signal is weak, then it is going to make it as amplifier. If attenuate means if the signal is very high, it is going to make into low value or average value, and it is attenuation we are going to. So this attenuated or amplified signal is fed to the analog to digital converter. This input of analog is converting into digital. It is going to counter here. Now convert that converted, it is going to fall on the counter. It is going to count the number of pulses. It is going to count here. Now triggers, it is going to count that triggered value. It is going to read out that one. So we will get the display of which is in proportional to the input signal, which is proportional to the input signal. This is the working of that one here. Now, so there are 5 types of digital voltmeters are there. Based on their operation, their outputs, there are totally 5 types of digital voltmeters are there on the basis of analog digital conversion method here. How they are going to convert the analog to digital conversion method. Based on that, digital voltmeters are classified into 5 types. That is called ramp type digital voltmeter, integrating type, potentiometric type, successive approximation type, continuous balance type here. So these 5 types are there. This one we will discuss in the tomorrow class. We will discuss. Okay. So this is very easy chapter is that this one actually. So operation of all the 5 types is the same like this only. But the types is depends on this circuit here. Now analog to digital circuit, it is depends on that. So only we are going to concentrate this one here. These all the 5 types we are going to concentrate. Okay, so we'll stop here only and we'll continue in the next class.